pleasure to be here, and I hope you will find this session interesting. Is there anyone here in the audience that knows anything about satellite communications? Okay, I will try it from the basics so we will understand what I'm talking about. But I started a company in Sweden in 2004 that worked with satellite communications. We have been developing different type of products and services. And we was awarded in 2015 as the fastest growing company in the northern part of Sweden. And I sold the company now in 2017. And we are now in Mexico, try to present some new solutions that I hope can be beneficial for Mexico and South America as well. We work in more or less in all industries. The prime industry is broadcasting, where you transmit, for example, a football game or news. If some big accidents happens, you go out, you transmit it live. But also we've been into the military industry, and we've been working all over the world. For example, I've been in 45 countries now, and I hope to visit a couple more. This is one of the solutions that we made recently. It's made for the European market, and actually it's more like an internet connection. So you can stream audio or video over internet. And this car is very easy to use. You only use one button and it will handle itself. So it will find the satellite, it will create the connection to the internet, and you can start streaming audio and video. So you only need to turn on your camera and everything is working by itself. We have also integrated a 4G technology. So if you have a good 4G network, you can stream over the 4G network as well, or you can connect it to a LAN network if you have that opportunity. So wherever you are, you have always possibility to be connected in the best, cheapest way in Europe. And we are thinking maybe make the same solution for South America as well. A little bit about the basic about satellite technology and how it's been working for more or less 30 years now. We always have one antenna on ground. If you are transmitting a football game or news or anything else, you are transmitting over satellite and you're transmitting home to your base studio. Or if you are a military organization, you transmit home to your base station. This is now evolving quite a lot, but I will come to that a little bit later. But this is the basics. Transmit up to the satellite, and you will receive the signal to another location. And it's only one-way communication. And also, the old type of satellites is illuminating a specific part of the world, like a big spot. And you are a little bit limited. You have a frequency band that need to be shared, everybody using this. So it's quite limited how many can be connected at the same time. It's often used as a distribution of TV to home. You have your small antenna you put on the roof and you can watch TV. So, what is happening? Before, all the satellites has been geostationary that we have up here. And it's sort of standing still. It's turning the same pace as the Earth. So you think it's standing the same position, but it's moving inside a box that is 1,000 meters in a square. But for us, it's standing still. But what's happening now, it's lots of more networks being evolved, called medium Earth orbit satellites that are closer to Earth, but it's turning quicker. Otherwise, it will fall down to Earth again. So you need to actually follow the satellite to be able to communicate with it. And at the same time, we have something called LEO satellites, low Earth orbit satellites, that even closer to Earth. So maybe you can see it when it passes the sky for 8 minutes, which put even higher demands on the equipment on the ground, because you need to track the satellites all the time. So, what is happening next? Now is something coming high power, high throughput satellites, HTS satellites. It's not especially new. The first one was deployed maybe 10 years ago, but very, very few people knows about it. And we've done a lot of presentation here in Mexico as well. And I think nobody has heard about it before. But I will try to explain the differences between the old type of satellites and this new technology, and what is the beneficial to actually use this type of satellites instead. So before we saw a big spot, the old satellite was illuminating a specific part of the Earth. Now this spot has been divided by many, many, many small ones. So this frequency band that we had can be used many, many, many times, and that will increase the actual bandwidth the satellite has. So we can send more information, and we will have a cheaper bandwidth to provide. And this can be used on all types of frequency bands. It can be used in all parts of the world, and it can also be used for all these specific satellites, MEO, GEO, and LEO satellites. So this technical advancement will improve the bandwidth from 20 times up to 100 times more. At the same time, it's going to be much cheaper to use the satellite capacity. So this is a picture of the MEO satellites that is a little bit closer to Earth. And you can compare it to a fiber connection. You have the same delays. You can do up to 2 gigabits per second in data rate. And that is really high. So now there are several companies in the world shooting up these satellites, and they are already working, but it's always evolving. So I don't know, maybe now it's 5 different networks that is actually working. And as I said, really, really high data rate. And the next evolution of the satellite industry is the LEO. It's really, really close. So now they're deploying satellites that will cover the total Earth with satellites. So this is one of them, OneWeb. So they're going to deploy 650 satellites around the whole globe. And you will have higher speed than fiber, less delays than fiber. And before, building satellites was really, really expensive. It was billions of dollars just for one. Now they are producing more or less 1 satellite per day. So they have changed the production methods, because otherwise it would be crazy expensive. More than it already is. It's $3 billion to build up this network. And at the same time, you need to get the satellites up to space. So there have been a lot of work to improve the launching process and actually reusing the same type of satellites, so you can set up more and more satellites with the same equipment. That will reduce the cost. And to be able to do this, as I said, we need to follow the satellites now in space instead of pointing at one specific. The old type of antennas was this. It was a mechanical antenna. You can maybe use it for some other trackings. But now they have developed metamaterials called phase array antennas. They work the same way as this antenna does. It's a flat panel antenna, And with phase shifting, they can actually steer the signal in any direction instantly. So you can put this antenna on top of a car, a boat, airplane, whatever. It can move at the same, it can track all the satellites. So you have high-speed internet access in your car, your airplane, more or less anything you want. You can use it for fixed application as well. And one of the big markets was actually provide high-speed internet access to schools in Africa. Imagine you can be in the desert somewhere, you can put up a solar panel, you can have a small antenna for receiving these satellite signals, and you can be actually connected with high speed. And this is one of the 2 companies now that is competing to have the first antenna ready. And Kumeta, I think, has sold the first 200 antennas for a military application. But this is really, really expensive, so they have Bill Gates is one of the co-owners, and that's maybe tells a little bit how much money they need to put into this to make it work. I know it's maybe 4 or 5 more companies working on this technology as well, but Kumeta has been the first one out. Phaser is the other one. And this will be integrated in the actual body of the airplane. So you will not see anything sticking out of the airplane. It will be integrated to the car, to the flight, to the body of the aircraft. So this is really, really high tech. So this is a little about what they're thinking to use it. They will integrate it. I think they have written an agreement with Toyota. They will actually build in these small antennas in the roof of the car. And the cars now start to be self-driving, self-learning. Only to do a software upgrade on a Volvo XC90 is 65 gigabytes of data. If you take it into service, it's 4 hours just to download the software to upgrade the car. If you have high-speed connection already in the car, you can more or less send an SMS to the driver. Please, we're going to update your software in the car. Can you please stop for maybe 5 minutes? We can have live video streaming for the kids in the back seats. They can be playing online games. So more or less it's the imagination will put the limits. You can do anything if you are connected. So this is the infrastructure of the future. If you don't have the possibility to have fiber networks, high-speed 4G networks, or the coming 5G networks, you can use the satellites instead. So you can build up networks, so you can build up local 4G networks in the middle of nowhere, as long as you have power. You can have data centers with phased array antennas. And of course, airplanes, humans, cars, everything can be connected at the same time that everything is moving. So, what is the big markets for this type of the new evolving markets? You have the old business where I come from, broadcasting, but it's only 3% of the total amount of data going to be used, because broadcasting in Europe, for example, they don't use satellites anymore. They use 4G networks. They have maybe 6 SIM cards, and they bond all of this information to get a high-speed access. So they can actually stream audio and video everywhere. I think I have met customers in Yugoslavia and other countries that don't have any actually good network, but it still works to stream. Government, I think more or less All governments want to be connected. It's a way of helping people, provide services, security. And the other one, we were talking about mobility. Now you can start surfing when you're on an airplane, but sometimes it's really, really bad connections. Okay, they can provide a service. When you try to use it, it doesn't work. Well, imagine it's 150 people on the plane, and you get maybe 10 megabits of data coming in. If you divide that for every person, it's nothing. But if you can have a gigabit connection for a plane, you can sit and stream video, you can play online games when you're flying. Backhaul, that I've been talking about as well. You can build up 2G, 3G, 4G, 5G networks without building infrastructure. You can actually just put up an antenna and then build up a local 4G network. So it's going to be really quick and easy. Enterprises, as I said, we had a very interesting meetings here in Mexico now with big companies, and they're also really interesting to have high data rates. Because if you don't have the infrastructure, just put an antenna on the wall and you will have high-speed internet anywhere. Broadband, yeah, that's for streaming, audio and video, computer games, everything. And then we come into Internet of Things. It's been a talk about Internet of Things, I think, for 10 years. But I think now it's actually starts to happening. And in Sweden, for example, they talk about smart industries, smart cities. Actually, here in Mexico, we have Cozumel. They want to be a smart island. But they can't be a smart island if you don't have connectivity. And it's really, really expensive to put a fiber cable out to the island. So we're going to provide them with some internet access over satellite instead. And the future, everything going to be connected. We are only maybe halfway. But at home you can have your fridge. We will send you an SMS. You need to shop out of milk. Your car is going to be self-driving in a couple of years. Already now you have an app. You can check the cameras in the Volvo, see what's around it. So you can see exactly where it is. So it's only start to happening this. And this is evolving really quickly. The first computer was connected to the internet in the 1950s. Students started to use it in America for connecting all these universities. I think during the 2000, more or less everybody got a PC at home. I did. And now everybody has a smartphone. You are connecting, you're surfing every day. You use social media. You use YouTube. And this start to create a lot of money as well. As I said, now the cars are connected. We're going to have smart homes. Everything is connected inside as well. And then you see this curve, it's only pointing straight up. And it's going to, by 2025, $6.2 trillion, this industry is going to have a turnaround. So it's huge. So the conclusion, why do the satellite industry do this? When we have 4G, fiber, everything else. Because we have 60% of the world population that don't have connectivity today, or really bad connectivity. And if you're going to start using Internet of Things without internet, there are no things to provide. So the satellite industry has seen this, and that's why they're building up these huge networks on new type of satellites that can provide you with high-speed internet. And one of these LEO networks is $3 billion, only the network. And there are 5 companies that are building up it now, and it's totally 12 who has applied for the rights to do it. So this was a short presentation about Internet of Things. And if you have any questions, please, I'm here for your sake.
How much does cost the suit that you show at the beginning of the presentation?
The car?
Yeah, exactly.
That's around $60,000. Yeah. And compared to the old technology, it's cheap because the old type of trucks cost $350,000 instead. So we are talking about satellite communications, but it's easier to say it's internet connection because you will have your small modem at home. It's like a DSL modem, but it's connected to a satellite dish instead of the connection on the wall. Any other questions or thoughts about a new way of being connected? No, as I said, you shouldn't see it as a satellite link, see it as an internet connection. Before you was transmitting point to point, now you're transmitting over satellite down to a hub station that is connected to internet. So it's a real internet connection. It's a bridge, only a bridge for internet that is a high speed. So if you want to build local 4G networks, you got high speed internet access. So it's compatible to all technology that already exists. So that's make it so easy. We will only plug in your cables, like in a normal modem, and you will have internet access. So it's basics, simple. Okay. Anyone else that have any questions?
What's your main customer here in Mexico?
As I said, this is my first visit to Mexico actually. But we had a lot of interesting meetings and there's a lot of interest for this type of technology. And the thought is to start up a business here. And this is more like a check in the market and see what the interest is. And also it's much better than home. We got 1 meter of snow and yesterday was minus 30 degrees Celsius. So it's really, really cold at home. Anything else? More thoughts? No? Okay. Everybody understands anything about satellite communications now? Yeah.
Who was the customer, and do you think an actual customer would do those things? I was reading about, I'm not studying communications, I'm studying renewable energies.
Okay.
And that is very important. Communications is very important because it's a new career, so that's why I'm here. And I read about many boys that went into Duma, in Syria, Duma, with solar panels providing energy to those cities. And well, it's energy, so it made a difference. And I was thinking, do you need a customer to make those projects in that kind of in that kind of cities, or do I need to buy you something to make those projects? My doubt is, are you thinking about any projects like those?
Sorry, didn't really understand the question. Can you please?
Are you thinking of any projects such as providing energy to rural
Areas.
communities that are not your customers, that won't pay you? Uh,
Yes, yes.
yes. Yes, I
Yes.
went too far away. I went to Syria, but like in United States maybe, or here in Mexico, or in everywhere.
Yes, that's why the satellite industry has developed these new satellites to be able to provide the service for rural areas, even if you don't have electricity. We can build up solar panels with battery packs, so you can always be connected. So it's very, very easy, even if you don't have any infrastructure, not even electricity, you can always be connected. I hope that's, or the
Okay, yes.
It's possible that use this kind of project or process or service for
Uh,
different industries.
were you thinking of any project like that, or or, or you as
for
in the
the moment,
CEO?
we are on the beginning to start this. So if there are any products like this, we are of course interesting to help to get people connected. But I don't have any product for the moment that I'm working on. Yeah, thank you.
Yes, sorry, I have a question.
Yeah.
How can we start thinking of our security in a world where everything is connected?
Sorry, if security.
Yes, in a digital world where everything is connected, how can we make sure we are safe in a world like that?
I know now it's a lot of cameras in Mexico City that's not connected, maybe. And if some part of Mexico doesn't have internet access for the moment, we can provide the internet access and they can build up maybe cameras or whatever that can improve the security in these places. He was talking to a transportation company that have trucks. They use 4G connectivity to know what the trucks are. But the people robbing the trucks have been smart, so they actually have jamming devices, so they can jam the 4G network. So they think they can't do anything. They don't know where the car are. But if they have a small satellite antenna instead on top of it, it's really difficult to jam it out. And it's new technology. I don't think the bad guys know about this yet, and they need to maybe develop new ways of interfering with this type of signals.
The antenna, where is it?
As I said, the LEO networks don't exist for the moment, but they are starting to shoot up satellites. So during next year, it's going to be in operation, OneWeb, but it's LeoSat and several other networks that is deployed as well. And the antenna actually exists. They have sold the first, I think it was 50 antennas. And as I said, it's a lot of money putting into the industry to develop this type of antennas. So it's gonna be, it's yes.
That is the main core business of submission. You build the antennas. I mean, you develop the technology.